In this video, we'll be looking at vertical sinusoid translations. Recall that y equal x squared plus 3 moves the basic graph y equal x squared up 3 units. So this plus 3 back here makes this basic graph go up 3 units. And y equal x squared minus 4 moves y equal x squared down 4 units. Well, this parameter change behaves the same way for a sinusoid. The graph of y equals sine x plus 3 is going to be moved up 3 units. So our center line then, instead of being the x-axis, is moved up to y equal 3. Our sine curve, however, is the same sine curve. Remember that the sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is 0. But when I move that up, then you add 3 to each of these. So instead of having a y value of 0, you have a y value of 3. Now, to conserve space, sometimes you'll see that curve shown this way. The x-axis, or the horizontal, is still labeled the same way. It's just that instead of moving everything up and showing the whole coordinate plane, we show this horizontal axis at 3. We just label it at 3. And since my amplitude is 1 here, then I subtract 1 and show a 2 on this axis, and then add 1 to show a 4 here. Let's do an example. We're asked to graph y equals 4 plus 2 sine theta. Notice that this one is a little different in that this equation, we added our 3 on the back. So we have our trig function and then plus 3. And on this one, we're adding our constant in the front. So this is the up 4. And this 2 right here shows my amplitude. So I'm going to go with the conserved space method of graphing. I'm moving my curve up 4, so I'll label this as 4. And then if I need an amplitude of 2, I'm subtracting 2 to get my lower guidelines. These are my guidelines for my minimum values. And then add 2 to get my maximum values. So, and I always use the dotted line for these as guidelines. And then my 4 quadrants are represented here. This is in theta, so I'll label my horizontal axis as theta and my vertical axis as y. And then let's label here as degrees. So 90, 180, 270, 360. This is a sine curve, So I start at the horizontal axis and I move up to the maximum for 90, back to the axis for 180, down to the minimum for 270, and back to the axis for 360. So my curve looks like this. Let's do another one. Again, my constant is added in the front. So this is telling me to move down 10. And my coefficient of my cosine is 4, so I have an amplitude of 4. And also notice that the coefficient of my cosine is a negative. So I need to make a note to myself that I need a negative cosine curve. So I'm moving my curve down 10, so let's label this horizontal axis as negative 10. And then my amplitude is 4, so subtract 4 makes this negative 14 right here, my minimum values, and add 4 will give me a negative 6 as my maximum values. And then let me show my 4 quadrants. This is theta, and this is y. Now, remember we had a negative cosine curve, which means that the normal basic cosine curve starts at a positive 1. But since this is a negative cosine curve, I need to start down here at negative 1. But it will be negative 14 in our case. So there's my minimum value. And then I'm going to come up and hit my axis. And then hit the maximum, hit my axis, hit the minimum. So my cosine curve looks like